what do we know? I know that is a quadratic because it's got a little exponent 2 thingy there. Makes it squared, makes it a parabola shape. B could be 0, C could be 0, but can A be 0? No, because if it is, then it's just 0 and that's not a quadratic anymore, right? That's called, and it depends on the textbook, some of them call it standard, some of it call it general form to write a quadratic, okay? We don't care which one's which, I'm going to call it both. We also know that if I put that in my calculator, given some numbers for R and S and A, does that also make a parabola shape? Yeah, because there's an x squared term there. So that we're going to call factored form. That's what we did in 7.4 and 7.5, which will show up on your quiz tomorrow. 1 or 2 questions. Okay, so the quiz says 7.1 to 7.5. That means kind of everything we've done up until this point. Okay, so it's all fair game. Who knows? Might even throw a banana on there. Okay, because we've done that a couple times now, and you had it on a project. We should be getting pretty good at that stuff, right? So, what's new today? There's another way to write this. And like a lot of things in English, it's like, why have one word to say something? We can have like 5 other synonymous with it. Same thing with math. Okay, there's one form, there's another form. What is vertex form? You guys know what a vertex is? What's layman's terms for vertex? If I'm talking a parabola. Yeah, the lowest point or the highest point. In this case, it's a lowest point or a minimum. That's where the vertex is. Or it could be the maximum, the highest point. That's the vertex, right? That's when this thing stops getting bigger and then starts getting smaller, or vice versa with the other one. So we can find that out if it's that way, and you can find that out if it's that way. Your calculator can do it, and I hope you know how, and if you don't, well, ask. But now there's a form to write it in that way, which is called vertex form. So, and other books use different letters for H and K. This one uses H and K, so that's what we're going to use. I know the pre-calculus book, it's P and Q, but who cares? A variable is just a variable. I don't have to call that Y. Remember, I can call that a function of X. Same thing. It's just a variable. But what's cool about this is, if it's in that form, H and K is the coordinates of the vertex, which is kind of handy. If you want to know what the vertex is, then it should be an easy mark, right? I don't even have to put on my calculator to find out. And what do we know about A again? If A is positive, which one is it? The up one. So this thing opens, yeah, up. If A is greater than 0, it opens up, right? If A is less than 0, i.e. negative, then it opens down, right? But do you even have to memorize that? No, you can just plunk that in your calculator, put in a negative value for A, and you will see it'll give you that shape, okay? Irregardless of what R and S and all these other letters are. So, example. Y is 2x minus 4 squared plus 3. What's my vertex? Remember, vertex is always a coordinate point. There's an x and a y there. And the x-coordinate of your vertex is also where what happens? Like if that's, say my grid's like this, right? That's like 8, -2. What also happens at 8? Yeah, that's the axis of symmetry. So if it's asking you both things, well, you're just going to find the vertex, and then you got both things solved there. Axis of symmetry is always x equals something. Vertex is always a coordinate point. So you could just put this in your graphing calculator and calculate, is it a minimum or a maximum here? How do we know it's a minimum?
Because it opens up.
Because A is, yeah, positive, right? Okay, so I know this thing's a minimum, but is this in a special form for a quadratic? Is this in this form? Does it look like it looks like that?
Yeah.
It sure does. And if it's in that form, then H, which is 4, and K is 3. So that's the vertex. Piece of cake, eh? Do I need to put it in my graphing calculator to prove it? Or do you believe me? You believe me, Sveta? Question? You were saying something. Okay. All right? Yeah. You want it in vertex form. At least kids in pre-calculus sure liked it in vertex form. Now they do a lot more with this kind of stuff. All right, but is that in vertex form? And again, this is just a visual exercise. You got to know. You can't ask me this in the quiz. Is that in vertex form, Mr. Watson? Sorry, can't help you. When in doubt, put it in your graphing calculator and calculate it. Okay? Is it? Does it look like that? What's A? -1. Does it open up or open down? It opens down. Yeah, it's flipped over the x-axis or wherever the vertex is. H here is 1, and K is what? It's -2, isn't it? Now to make that look exactly like that, is that the same thing? Yeah, that just says -2, doesn't it? When we write -2, we don't go plus -2. That's kind of redundant. It's as redundant as going, if it's 2, I don't put a plus in front of it. But this is now in exactly the same form. K is -2. Okay, that's where the vertex is. Now why am I overemphasizing that? Because this one actually is a negative, isn't it? Okay, so guess what happens if we got something like that? What's my vertex? See, that's in this form, but this has to be a negative here for H to be positive. So if this is a positive, what's another way of writing this? That's still A. It's positive, it opens up. Could I do this? I know it looks kind of busy, but here, clearly, it has to go x minus, this is h. So x minus, what's h here? -3. See how it's kind of backwards? Okay? So if it's a plus, the vertex is a negative. What's k? Yeah, again, you can think of it like that. Plus k is -4. Let's put that one in to prove it. On. Guys want to see what they're doing in grade 12? It's a sine wave. Okay, 2/5. How do I put in 2/5? 2/5. bracket x plus 3 bracket squared minus 4. How's my windy? Oop, that's not going to work. Negative 10 to 10. That's your standard, right? If you have to move it after this, then you move it. But that's probably where you want to start. I want to know what's happening around the origin. Okay, does it look like negative 3, negative 4? Sure does. Okay, that's negative 3. 1, 2, 3, that's negative 4. Boom. Hang on. Okay? So again, you can do this to check, but we shouldn't have to. All right. Y is x squared plus 2. You remember graphing this thing in the first sheet I gave you? Do you guys know what x squared looks like? Y equals x squared? You got a mental picture with that? That should put an image right in your mind. You know what that looks like? That's the most basic parabola you can have. Looks like that. Okay, if x is 0, y is 0, there's your vertex right at the origin, 0, 0. What does the plus 2 do to y equals, that's y equals x squared, right? You remember?
Moves it up too.
Good. Moves it up too. So it's not there. Same shape. It's just up there. So what's my vertex here? Well, let's actually put it in vertex form. Does it look like that? Not really. But I could write this like this, right? I could go x minus 0 squared. What's a here? What's the amplitude? It's just a 1, right? Did I say amplitude? That's not a word you know. Sorry. And then I got plus 2. So again, x minus h squared plus k. That's vertex form. Do you see now what h and k are? H is 0 and k is 2. Just like if you remembered, hey, it works. What do you know, right? Okay? So it didn't really look like vertex form, but it actually kind of was. So I don't know how you want to think about that. Okay, we talked about if they open up or down. Let's do something else. Let me take you out on a limb here. Let me dangle another carrot cake, carrot piece in front of your nose. Huh? What's another word for an x-intercept? 0. Roots. Good. Okay, we're all getting that? Again, there's 3 ways to say the same thing, right? Kind of like this. 3 ways to write a quadratic. Without graphing, are you able to figure out how many x-intercepts there are here? Knowing that's where your vertex is, and knowing if this opens up or down? Just do a quick little picture. This is my vertex, 4, 3, kind of over there somewhere. Does this open up or down? We already said it, but let's say it again. It opens up, it's positive, right? How many times, bad parabola, but how many times does that cross the x-axis? It don't, and that's okay. A parabola can have 0 roots. How about this guy? My vertex is 1, negative 2. Does this thing open up or down? Negative. Opens down. How many x-intercepts does this guy have? It also doesn't cross the x-axis, does it? How about the next guy? Negative 3, negative 4. It's down here somewhere. Does this thing open up or down? Positive, opens up. I could put it in my graphing calculator, but hey, if I'm clever, I don't need to. How many x-intercepts does this have? Yeah, I mean the grid, just Oh, good. Just because I didn't drew it there doesn't mean, you know, it stops, right? This is an x-axis, goes forever and ever and ever. Clearly, I've got two x-intercepts. Now, why do you want to know this? You're saying to yourself, oh, I could just graph. You know how many times people all of a sudden can't graph something? What if that's 2/50ths and that's minus 143 and you're not clever enough with your window and you can't find it?
Then you need to figure out the windows.
Yeah, SOL is the math term for that, right? So I don't even need to graph, and that might take 10 minutes. Hey, you guys only got an hour. I'm giving you 18 to 20 questions. We should know. I don't care what this says. That could say 4,650. I don't care. I know it opens up, and I know where my vertex is, okay? Even if it's way down there, this is going on forever and ever and ever. I still got two x-intercepts, okay? And this guy, of course, will have none also, right? Okay, so we'll give you some questions like that. Again, if you can't get it by the way I'm teaching it, at least you can still use your graphing calculator and get the marks. But if you can't understand and follow what I'm doing here. Okay, last one for the big kids. Are you a big kid? Yes, you are. Determine the value of A. Have we done this before? Yes, we did. But it was in factored form. Now it's in vertex form. And hey, wasn't this on the project Friday? Well, many of you did the two questions and handed it in. Okay, it's not that hard. Just because we don't write it, we show a picture of it, you still know the x-intercepts. You still know another point on the parabola. This is now the same thing, only it's not a picture. I'm just telling you what it is. So that doesn't say find the whole equation of the parabola, but you basically have it right there. The only thing you don't know is A. So that's all it's asking you. What is A? If this is a quadratic, and that's a point on it. Well, what do we know about this quadratic? Does it open up or down? Are you sure? What if A is negative? You don't know yet, do you? No, you didn't. Okay, but what do you know? That is in vertex form. What is the vertex?
3 and 4.
Careful. Whoop. H. That, by the way, you don't have to memorize. Of course I'm going to give you that. Okay? If it's a minus, that's just H. K 3, 4, but remember this is an opposite sign here. So that says x minus minus 3. H is minus 3. Okay? That's my vertex. Roughly, negative 3 and 4, it's there. But I don't know if it looks like that. It looks like this. It looks like that. It looks like that. Or maybe it looks like that. Maybe it looks like this. This is what A does. It tells you the shape of that thing. Yeah, it kind of looks like a spider, doesn't it? Only he's got too many legs. Gonna have to pull a couple off. Oh no, he doesn't have enough. By the way, you can actually make that picture in your graphing calculator, given patience. Okay, that's what A tells you. How the shape is. All of those have this vertex. What is A? Well, what do? Only one of these points, negative 1 and 16, is on this parabola exactly. Okay? That guy right there. That's the only one where that point is on. All the other ones miss that point. So remember, this is an equation for every single point on this parabola, right? A unique equation for that parabola. So if that's a point on the parabola, it's got to work in that equation. What's the word? What do I do? Starts with an S.
Substitute.
Substitute that point in here and solve for A. What's another word of, well, what's another way to say f of x? Yeah, so y is a, what's x? -1 squared plus 4, and y is, I guess I should have done that too, y is 16, right? One equation, only got one variable, I can solve for it. With a little bit of math stuff. Bedmass. Brackets first. What's -1 plus 3? 2. That's all I can do in the brackets. Just rewrite everything. Okay? Step 1. Bedmass. Second letter says E, means exponents. Do the exponent. What's 2 squared? 4. plus 4 is 16. Okay? This was grade 11. Now we went back to grade 10. Now we're back to grade 9. Or 8, if you had a good teacher. That's a two-step equation. How do I solve it? Get rid of this plus 4. What's the opposite of plus 4? Minus. Whatever you do to one side, do to the other side. 16 minus 4. 12 is A4. I want A, not A4. How do I get rid of that 4? Divide it away. It's A times 4. The opposite of times is divide. What's A? Okay, it didn't say find the new equation, but put 3 there. That's the new equation, right? That's a unique parabola that goes through that point. Okay, 417. This is not on the quiz tomorrow, but it will be on the next one, Monday, Friday. Yes, that's in the correct order. I want you to do 5 before you do 4, okay? I don't remember why, but I must have had my reason.